Hello everyone, I am Yamala Padmavati and my teammates are Peruri Sirisha and Tota Purnima. As a part of IOT internship at Emertxe Information Technologies Private Limited, we did a project on IoT based home automation solutions. Based on this, we did a PPT and the contents covered in this project are Introduction to C programming, Introduction to IoT, Introduction to embedded systems, required components and software, and the requirements are garden light control, temperature control system, water tank inlet and outlet valve control, and the user interface used in this project is Blink application, and then conclusion. And the contents covered in C programming is Introduction to C language, data types, conditional constructors and operators, arrays, pointers and functions. Then recursion, constants with pointer and strings, pre-processing and storage classes. Next, what is IoT? The Internet of Things describes the network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and enhancing data with other devices and systems over the Internet. And thermostats, cars, lights, refrigerators, and more appliances can all be connected to the IoT. Next, what is home automation? Home automation refers to the automatic and electronic control of household features, activity, and appliances. Home automation is a way to control all the gadgets of your house with your convenience, thus saving power and cost. You can handle all your gadgets such as lights, temperature, water tank, etc. with the help of your smartphone through the internet. And the purpose of this project is the home automation system is to streamline how your home functions. Consider some of these benefits. First one is remote access and then comfort. In remote access, control your home from mobile devices including your laptop, tablet or smartphone. In comfort, use home automation to make your home more comfortable, livable space. Coming to introduction to embedded system, as its name suggests, embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system having software embedded in it. An embedded system can be an independent system or it can be a part of a larger system. An embedded system is a microcontroller or microprocessor based on system which is designed to perform a specific task. For example, a fire alarm is an embedded system. It will sense only smoke. An embedded system has three components. It has a hardware, it has application software, and it has real-time operating system that supervises the application software and provide mechanism to let the processor to run process as per scheduling by following the plan to control the latencies. RTOS defines the way the system works. It sets the rules during the execution of application program. A small scale embedded system may not have RTOS. And these are some of the examples of embedded system: laptops, mobile phones, landlines, robots and cameras, CC cameras, etc. And my teammate Sirisha will continue from the next slide.
Hello everyone, my name is Sirisha. Coming to the next slide, that is required components for this project: Arduino Uno, Ethernet W5500, PCF 8574, temperature sensor, LED HD 44780, LDR sensor. The next one is software used for this project: PIC SIM lab, Arduino IDE, Blink software. The next one is Arduino Uno. Arduino Uno is a microcontroller board based on the 80 mega 328 datasheet. It has 14 digital input output pins, of which 6 can be used for pulse width modulation outputs, 6 analog inputs, 16 megahertz ceramic resonators, USB connections, a power jack, and ICSP header and a reset button. It contains everything needed to support the microcontroller. Simply connected into a computer with a USB cable or power. It will be a AC to DC adapter for battery to get started. This is the Arduino Uno board. In this Arduino Uno board, there are USB cable ports, and there are digital input output pins are there. The next one is Ethernet W5500. This is the Ethernet W5500. The W5500 chip is a hardwired TCP or IP embedded Ethernet controller that provides easier internet connection to embedded systems. W5500 enables users to have the internet connectivity in their appliances just by using the single chip, in which TCP or input stack, 10 by 100 Ethernet MAC, and PHY embedded. This is the Ethernet W5500. Coming to the next slide, that is the PCF 8574 is a silicon CMOS circuit. It provides general purpose remote input output expansion for most microcontroller families via the two-line bidirectional bus, that is I2C or I2C. The device consists of an 8-bit bidirectional port and an I2C bus interface. The next one is temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to reader, monitor, or signal temperature changes. This is the temperature sensor. In this temperature sensor, 3 pins are there. One is voltage pin, another one is output pin, and another one is connected to ground. The next one is LCD HD44780. HD44780 is a dot matrix liquid crystal display controller and driver. DSI displays alphanumerics, Japanese kana characters, and symbols. It can be configures to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microcontroller. This is the LCD display. Coming to the next one, LDR sensor, a photoresistor or light dependent resistor. LDR or photo cell is a light controlled variable resistor. The resistance photoresistor decreases with increasing incident intensity. In other words, it exhibits photoconductivity. Coming to the next one, software requires. First one is PIC SIM lab. PIC SIM lab is a real-time emulator of development boards with integrated MPLAB X or AVR GDB debugger. PIC SIM lab have integration with MP Lab X or Arduino IDE for programming the board's microcontrollers. The next one is Arduino IDE. The open source Arduino software IDE makes it easy to write code and update it to the board. This software can be used with any Arduino board. Requirements: garden light controller. This is the garden light controller structure. In this garden light controller structure have Arduino Uno board is connected. Arduino Uno board is connected to LDR sensor. This is the input sensor. It displays the light, that is this process of Arduino LDR sensor is read the LDR sensor value based on the reading from LDR, vary the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight. This is the garden light controller diagram. This is for garden light controller. And then coming to the next one, Purnima will continue with the next topics.
Hello everyone, I am continuing with temperature control system. The temperature control system consists of heating resistor, an LM35 temperature sensor and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35, display it on the CLCD. Control the temperature of the system by turning on off the heater and cooler through the Blink IoT mobile app. This is the block diagram for the temperature control system. Requirements are temperature control system, cooler control system, heater control system, threshold temperature control. Now we will discuss about water tank inlet and outlet valve control. Read the volume of water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Display the volume of the water in the tank on the CLCD. This is the block diagram for the water tank inlet and outlet valve control. Requirements are display the volume of water in the tank, inlet valve control, outlet valve control. Inputs are button widget on Blink IoT app. Processes detect the change in the logic level. Output is if the button widget is at logic high, turn on the outlet valve by sending commands through serial communication. If the button widget is at logic low, turn off the outlet valve by sending commands through serial communication. Requirements are control the volume of water in the tank. Now discuss about the user interface. Blink application. Blink was designed for the Internet of Things. It can control hardware remotely. It can display sensor data. It can store data, visualize it, and do many other cool things. Create widgets on mobile Blink application. Button widgets to control heater, cooler, inlet valve, outlet valve. Gauge widgets to display temperature and volume of the water in the tank on the mobile application. Terminal widgets to display the notifications whenever threshold is crossed, like temperature is more than 35 degrees. turning off the heater, water level is full, water inflow is disabled. Threshold control: when the heater is on, if the temperature rises above 35 degrees Celsius, then heater should turn off automatically, and message: temperature is more than 35 degrees Celsius, turning off the heater, should be displayed on the virtual terminal HD off on CLCD. When the water in the tank is full, turn off the inlet valve automatically and display water level is full, water inflow disabled. Now coming to conclusion, using Blink IoT application and PIC Lab in simulator, simulated home automation where LED temperature system, serial tank resembles light, heater, cooler and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater, cooler and inlet valve, outlet valve. Gauge widgets to display the temperature and volume of the water. Thank you.
Thank you.
Thank you all.